Hello everyone, you're welcome to this class. So we want to look at Pythagorean theorem, Pythagoras theorem. So and under this we'll be looking at these objectives. So we look at there's no way we talk about Pythagoras theorem, we'll not talk about right angle triangle. So because the theorem applied to right angle triangle. As you all know that we have different types of triangles. So we'll be looking at right angle triangle, then look at the rules application of Pythagorean triple. So a right angle triangle is this. It's a triangle that has a right angle, that is angle 90 degrees. So this is a right angle triangle. Now under this right angle triangle, there are some things you need to know under it. Now the side that is facing angle 90 degrees is called hypotenuse. Hypotenuse. While the remaining two sides are opposite and adjacent. If we are looking at angles, if there is an angle here, so the side that is facing the angle we are considering, apart from angle 90 degrees, is the opposite. Is the opposite. While the other one is the what? Adjacent. I hope I'm making sense. So this is the first thing you must know. You must know how to identify the sides. The hypotenuse, the opposite, and adjacent. So if the angle, if you are considering this angle here, all right, so this will be the opposite, while this will be the adjacent. That is what we call, that is the right angle triangle. So let me give you another diagram, all right. So if you have it, okay, let's have it this way. You have this, and you have this like this, and this is a right angle triangle. So the hypotenuse will be the side that is facing the right angle. This is the hypotenuse here. Right, hypotenuse. While this is the angle we are considering, this will be the opposite, right? And this will be the what? Adjacent. Please take note of everything here. It's very important. So that is that. Then what does the Pythagoras rule say? What does the theorem say? The theorem says, that the square of the hypotenuse is equals to the sum of the other two sides. Because the sum of the square of the other two sides, that is hypotenuse and adjacent. So that means, what this means is that hypotenuse squared equals to opposite squared plus what? Adjacent squared. I hope I'm making sense. So if we have this as this, we have this. So we then have A, B, C. So this side here will be this angle A will be what? The small letter A is the side facing it. While this is small letter B, while this is small letter C. Alright? So from here, this is the hypotenuse. This is opposite, and this is what? Adjacent. So this is opposite because I'm considering this angle, right? So that means hypotenuse squared, which means B squared, equals to A squared plus C squared. Alright. Now, one thing you're going to notice about this Pythagoras theorem is that this theorem is used to find sides of a right angle triangle. We used to find sides of a right angle triangle because so everything we have there deals with what? Sides. You cannot use it to find angle. You can't use it to find angle. So the same thing we can use it to find hypotenuse or adjacent or what? Opposite. We just make whatever we are looking for the subject of formula. If we are looking for C, we make C the subject of formula. If we are looking for A, we make the A the subject of formula, and so on and so forth. So that is that on the rule. Then the third one is application, and it's applied to solve for the problem of sides of the right angle triangle. So let's look at an example. So for example, we have this examples. find the marked letters. So let's have this. Find the length of the length marked. The length marked with letters. So we have the first one here. The first one have this. You have x here, you have 5 here, and the 12 here. Then the second one, so this is what we have there. Have something like this. Right, we have this. So this is the right angle. We have Q here. This is 10 centimeters, and this is 12.5 centimeters. So this is it. So we have to find the value of the letters there. So how do we go about that? So to solve this solution, the first one, so let's write this. Let's write it again. Alright, we have 5 units. So let's put centimeters there for meters. So 5 meters, 12 meters, and then x. So what you notice here is that the unknown side here is hypotenuse. The unknown side is hypotenuse. So the first thing is to identify this is the hypotenuse, this could be the opposite, and this could be the adjacent. Whichever one you put, you will be correct, right? So because we are not given any angle here, so we pick any one of our choice to be the opposite or adjacent. It's still the same thing. So now the rules. So we have to write out the rules. Hypotenuse squared equals what? Opposite squared plus what? Adjacent what? Adjacent squared. So the hypotenuse is x. That will be x squared. Please don't write only x. It is x squared. Then opposite squared is 12 squared. Adjacent squared is what? 5 squared. So that means x squared equals 144 plus 25. That is x squared equals to 169. So x will be equal to square root of what? 169. Therefore, x equal to what? 13 meters. As you can see, it's longer than the other two sides because it's the longest side and it's the side that is facing angle 90 degrees. I hope that's very clear. So that is that for the first one. Then for the second one, we have this. This is what we have there. So this is 90, this is Q, and this is 12.5 centimeters, and then this is 10 centimeters. So what you are going to notice here as well is that the hypotenuse is given, while one of the other two sides is what we're looking for. So this is the hypotenuse. Let's say this is the opposite, this is what? Adjacent. So we write the rule again. Hypotenuse squared equals to opposite squared plus what? Adjacent squared. The hypotenuse here is 12.5 squared. The opposite is what we are looking for. That is q squared. Don't just write q plus adjacent squared. That is 10 squared. So it is q that we're looking for. So find the square of this, find the square of this. Then make q the subject of formula. So that would be 12.5 squared. So gives us 156.25 equals to q squared plus what? 100. So we collect like terms. That will be 156.25 minus 100 equals to q squared. So that means q squared equals to minus 100. That gives us 56.25. So that means q equals to square root of 56.25. Alright? So that means Q equals to square root of, that is equal to 7.5 centimeters. I hope this is very clear. That is that on the application. So we still have questions that are more complex than this, but we're not going to look at that in this video. I'm going to do another video especially for that purpose, so that we'll be able to understand it better. So the next one is Pythagorean triple. Pythagorean triple. So just like Pythagoras theorem, so it's a set of three whole numbers that satisfy Pythagoras theorem. Is called a Pythagorean triple. What does that mean? So let's start these examples so you can understand it better. So which of the following sets of numbers are Pythagorean triple? So you'll be given three sets of numbers like this. So the highest of it will serve as the hypotenuse, while the remaining two will serve as opposites and what? Adjacent. So for the first one now, solution. For the first one we have there, we have 3, 4, 5. So if this is the case, so because this is the highest number here, this will serve as hypotenuse. So we can make this one opposite and make this one what? Adjacent. So we now test whether this set of numbers satisfied the condition for Pythagoras theorem. So this says hypotenuse squared equals to opposite squared plus what? Adjacent squared. So hypotenuse is 5 squared equals to opposite, that is 4 squared, plus adjacent, that is 3 squared. So this will give us 25. So we want to check if this one will give us 25 as well. This is 16 plus 9. And this gives us 25 as well. So therefore, we can say that 3, 4, 5 is a Pythagorean triple. Is a what? Pythagorean triple. I hope this is very clear. So that is that one. Then for the second one, let's check for the second one as well. We have 5, 12, and 13. So this will be the hypotenuse. This will be the what? Opposite. And this will be what? The adjacent. So that means 13 squared, hypotenuse squared equals to opposite squared, right? Plus adjacent squared. So that is 13 squared equals to opposite 12 squared plus adjacent 5 squared. So this is 169. This is 144 plus what? 25. So this gives us 169. So which means that therefore 5, 12, 13 is a what? Pythagorean triple. Pythagorean triple. How far making sense? Then the third one here, the third one we have here is 8, 15, and 17. 8, 15, and 17. So we also do the same thing. This hypotenuse, opposite, and then what? Adjacent. So that means hypotenuse squared, opposite squared, plus what? Adjacent squared. So hypotenuse is 17 squared, 15 squared, plus 8 squared. So let's check for this. Let's check for this as well. So 17 squared now, 17 squared gives us 289 equals to this one gives us 225 plus this one gives us 64. So 225 plus 64, that gives us 289. That is 289 plus 289. Therefore, these numbers, this set of numbers, 8, 15, and 17, is a Pythagorean triple. So if this is not equal to this, then the set of the numbers are not what? Is not a Pythagorean triple. Let's have one more. The one that will not be Pythagorean triple. So let's have the fourth one, 2, 5, 7, and see if they are going to be equal. So this is going to be hypotenuse, opposite, adjacent. That is hypotenuse squared equals to opposite squared plus adjacent squared. So that is 7 squared equals to 5 squared plus 2 squared. So this will give us 49, and is it going to be equal to 25 plus 4? So that is 49 is not equal to 29, as you can see. Therefore, we can then see that 2, 5, 7 is not a Pythagorean triple. Pythagorean triple. So I hope this is very clear. So that is that on Pythagoras theorem. So in our next class, we're going to look at more complex examples on Pythagoras theorem and the application of Pythagoras theorem. So I hope you find this video useful and helpful. Don't forget to give us a very big word, thumb up, and we're going to meet in our next video. Bye for now.